Hi, welcome to association rule mining, which is also one of the unsupervised machine learning algorithm. Association rules are simple conditional statements like if and then, which is used to find hidden relationships between the features, identifying the frequent item sets based upon the patterns and correlations between given features and target label in the given data set. For example, this data set is having two features and the label. So the association rule mining is used to find out the correlation between the features and the label, and also which is learning the patterns from the two features and predicting the creating the rule to find the relationship between the features and given label. The generated rules are used to find hidden patterns from the data set. And even though association rule mining is suitable for only non-numeric or categorical data, that means we cannot use the numerical number in the data set. For example, if our data set is having the numerical numbers as a feature values like this, then we cannot use this data set for association rule mining. So our data set should contain categorical values, then only we can apply the association rule mining for finding the relations between a label and given features. The association rule is having two components. That components are antecedent, which is if statement, and the consequent say statement, which is then. Here an antecedent is a pattern which is found in the data. Consequently, the consequent is used to find an item which is combination with antecedent. So once the pattern is found, then consequent is used to find the item that is related to the antecedent. Example, the departmental store is having so many association rules. In that, if customer buys a bread, he is 70 percentage likely of buying the milk. Likewise, if person is buying a bread, there is 70 to 80 percentage of likely of buying uh, tea powder. Okay, so like that we can frame the association rule for a given data set. Here the bread is antecedent and the milk is the consequent. So milk is consequent, bread is the antecedent. Based on this, we can use some of the parameters to frame the association rules. First one is the k item set. The item set is called collection of items. Here k item set, in the sense it will have k number of items. For example, one item set in the sense it will have only one single item in the single item in the sample. So egg is one item set and milk is one item set. So these are all called one item set. And two item sets, in the sense combination of two items, egg and milk, one two item set, and milk and bread is another two item set. Three item set, here egg, milk, bread, three combination, three items are combined, that is called three item set. And another parameter is support or support count, which is indicating how frequently if and then relationship appears in the database. uh, that is number of times the item sets appears out of all the transactions which are all considered for the processing. It can be expressed in percentage also. A support count of 65% for milk comma bread two item set, this is representing both milk and bread appeared 65 times in overall transaction of 100 times. That means out of 100 transactions of milk by or bought by the customers, 100 customers, in that 65 times bread also bought by the customers out of 100 transactions. So there is the possibility of association between milk and bread. Whenever a customer is buying the bread, milk also bought for 65 times out of 100 times. Whenever they are buying milk, bread also bought in this transactions combinedly. So this can be represented by using support of A implies B equal to probability of A union B. So the probability can be used to represent the support count in the association rule mining. Support of the rule A and B occurred together, which is equal to the probability of A union B. Likewise, another one parameter is confidence here, which is providing about the number of times these relationships have been found to be true. That means how many times that relationships are found true. Sometimes there is false, there is the possibility of false also. So we have to count the number of times that relationships found to be true. The confidence of 80 percentage for milk implies bread indicates 80 percentage of customers who purchased the milk also purchased a bread. So 80 percentage of customers whoever purchased the milk, they also purchased the bread. That is the meaning of A implies B, right? So milk implies bread. The confidence can be represented by using the probability. Confidence of A implies B equal to probability of B given A. Whenever they bought A, product A, that is given B also. The confidence can be denoted by using the support count also. Confidence A implies B equal to probability of B given A. This can be represented by using the support count. Support of A union B multiplied with support of A. Another one terminology, important terminology, frequent item set. Whenever the item set is uh, uh, meeting the minimum support count, then that is called frequent item set. For example, if the minimum support count value is 70%, then support count of two item set milk comma cheese is 60%. You look at that, minimum support count is 70, but the support count of the two item sets milk and cheese is 60%. Then this is not considered as a frequent item set. The frequent item set should have greater than or equal the minimum support count 70%. Then only it will be considered as a frequent item set. Suppose if I am having the egg comma bread, so this item set, two item set is having 72 percentage of support count, then we can say this is frequent item set, because which the 72 is greater than minimum support count 70%. The support count is decided by the subject matter expert, and the algorithm of association rule mining is given here. So this is the given data set which is having the transaction id and item set. So here item set is given. So from the uh, given transactions, we have to calculate all the frequent item sets from list of transactions. For each frequent item set L, first we have to generate all non-empty subsets of the item set L. First we have to create the non-empty item set. For example, M, then O. So like that we should create non-empty non-empty subsets of the item set L. Now for each subsets we have to create all candidate rules, that is S implies L minus S. So here L is called lift, S is called support count. Then candidate rule S implies L minus S in is an association rule only if it meets minimum confidence. We have to calculate the three things. One is frequent item set, and the next one is confidence, and the next one is support. So we have to calculate the three values. Based upon that, we can frame the candidate role. So these four steps are used in the association rule creation. How to find the frequent item sets from the large transactions? So for finding the frequent item sets in large transactions which consumes more time, so to here we are having different algorithms to find out the frequent item sets. So one of the familiar algorithm is a priori algorithm, which is finding the frequent item sets efficiently. uh, Three different algorithms are there to generate the association rules in data mining. First one is a priori algorithm, which is used to identify the frequent individual items in the given database and then expands them to larger item sets. First it will start with single item set, two item sets, then it will keep on extend into n number of item sets, then keeping in check that the item set is appear sufficiently frequently in the data set. And second algorithm is ECLAT, that means equivalence class transformer algorithm. Sometimes they will call equivalence class clustering and bottom up lattice traversal, which is better than a priori algorithm to find out the frequent item sets and generating the association rule by regrouping the frequent item sets. And third one is frequent pattern tree growth algorithm, which is used to finding the frequent item sets based upon the learning patterns, recurring patterns, without generating the candidate solution. It is mainly operates in two stages. One is uh, frequent pattern tree construction and extract that frequently used item set from the FP tree. Thanks for watching.